Okay, so we are beginning with the question of May 2021, question 1. May 2021, question 1B. That's where we begin. And the question says that Comp World Limited assembles and sells computers. The company estimates that if it optimally assembles computers, it could sell between 1,100 and 2,000 computers per month, and the monthly revenue in thousands of shillings over this range of sales could be represented by the function where R is the monthly revenue, X is the number of computers sold per month. Now the company estimates that its marginal cost in thousands of shillings could be represented by the following function, given that the fixed cost of the company amounts to 100,000 per month. If it is assumed that all the computers assembled in a given month are sold within the same month. So you are told to get first the total cost function. So when they ask for the total cost function, total cost function I told you there are three methods via which you can get a total. You can multiply, you can add, you can integrate. The method to use depends on what has been given. So in this case, we are given a margin. So we'll have to integrate. So we will say that the total cost is equal to the integral of the marginal cost, which is 200x squared minus 200x plus 400. Now we are integrating this with respect to x. And then I told you in doing this, you say 200x currently is power 2. You add back 1. You divide by the new power 2 plus 1. Then you say minus 200x currently is power 1. You add back 1. You divide by the new power. Then 400, which is currently x raised power 0. You add back 1. You divide by the new power. And then you add c, the constant of integration. From there, this becomes 200x cubed out of 3 minus this is 2, so it becomes 100x squared plus 400x plus c. But now c, we write the fixed cost. So the fixed costs, because these equations are in thousands, the fixed cost would be 100. That is the fixed cost. The next thing that we are told to get is the profit function. The profit function. Now, profit we know is given as total revenue minus the total costs. Total revenue minus total costs. Now, total revenue, we are already given 1,000x minus 200x squared. That is the total revenue. You minus cost, which is 200x cubed out of 3 minus 100x squared plus 400x plus 100. So you open the brackets to get 1000x minus 200x squared minus 200x cubed out of 3 plus 100x squared minus 400x minus 100. Then you put like terms together. So this 1000 to join this 400 so that we are left with 600x. This 200 square to join this 100 so that we are left with minus 100x square. This one does not have a colleague, so it is to remain 200x cubed divided by 3. And this one as well does not have a colleague, so it remains. That is the profit function. Then we are told optimal profits. So optimality. Now we normally say that at this point, the differential of pi with respect to x should always be equal to 0. The differential of pi with respect to x should always be equal to 0. So then, that is, if I seek to differentiate with respect to x, this function of 600x minus 100x squared minus 200x cubed out of 3 minus 100, we say should be equal to 0. Should be equal to 0. So in differentiating that, I end up getting 600 minus 200x minus 200x squared is equals to 0. That is what we get. Now that becomes a quadratic function. Therefore, I'll say using quadratic formula. Using quadratic formula. Now x should be minus b plus or minus b squared minus 4 is c. 4 is c. You divide all this by 2a. So b is this one, the 200. So when you make it minus, you are left with 200 plus 200 plus or minus 200 squared minus 4 times a, which is minus 200, times c, which is 600. Which is 600. You divide by 2 times a, which is minus 200. So this proceeds to become 200 plus or minus. This is minus 400. Then we get this answer. That is 200 squared plus 4 times 200 times 600 equals, you get the square root of that, I'm getting 721.11. So this becomes 200 plus 721.11. You divide by minus 400, or 200 minus 7. You divide by minus 400. So 200 plus 721.11 divided by 400 is negative 2.3, or 200 minus 721.11 divided by minus 400 is 1.3. So this becomes 1.3 units. And remember, these units are in thousands. Those units are in thousands. So when you have gotten that, you then proceed and tell us thus maximum profit will be equal to, now this value that we have gotten, you substitute it in this equation of the profit. This equation of the profit, which is 600x. So 600 times 1.3 minus 100 times 1.3 squared minus 200 times 1.3 cubed out of 3 minus 100. So solve that and give me the answer. Let me get the answer from someone. And anyone who has another question, you can give us. Beryl, you want to talk? So the answer that I've gotten is 364.53. 364.53. Okay. So if there is no one who has a question, then we can turn to the question of September 2021. The question of September 2021, question 4C. September 2021. Question 4C. Now, in September 2021, question 4C, it reads that a medium-sized company manufactures product Dovu. The current variable production cost per unit of Dovu is 800, while the selling price is 1150 per unit. However, demand for the product Dovu is uncertain and has the following probability distribution. So we are given that we are required to advise the company on the optimal number of units of product Dovu to produce using those rules. So that question is part of what we call single stage decision. It's part of what we call single stage decision. And it is single because you can see we just have one set of probabilities. That is the easiest way I told you to know whether you're dealing with single or multiple. You can see we have just one set of probabilities. And a set I said is what adds to one. Now, I want us to compute payoffs because the question has not given us. So, computation of payoffs. Computation of payoffs. We are going to have the option here. And this option is what we would call production. Is what I can call production. Then we have the outcome, and the outcome is what we call demand. The outcome is what we call demand. Then we will have units sold. Units sold. And these ones, I can call them A. Then I can have units produced, which I'm going to call B. And then the next thing now will be profit. Now we know so well that profit is revenue minus cost. Revenue is the selling price times the unit sold. The selling price is 1150. So I'm going to talk of 1150A minus the variable cost. Variable cost is the unit produced and the variable cost per unit, which are 800B. Then my question does not have fixed costs. My question does not have fixed costs. So now, the number of units that are produced are 10, 20, 20, and 30. So I can decide to produce 10, but demand turns to be 10 or 20 or 30. I can decide to produce 20 and demand turns 10, 20 or 30. I can decide to produce 30 and demand turns 10, 20 or 30. So those are the possibilities, the three possibilities, together with the three possible outcomes. Now, if I have produced 10 and 10 customers come, I will sell 10. When 20 customers come, I will still sell 10. Even here, I will still sell 10 because that is what I have produced. Then, that is 10, 10, 10. If I have produced 20 and 10 customers come, I will sell 10, although I have produced 20. Here, I will sell 20 because I have produced 20. Here, I will sell 20. I will sell 20, although I have produced 20. Here, I will sell 20 because I have produced 20. This other one, I will sell 10, although I have produced 30. I will sell 20, is a 30. I will sell 30 because I produced 30. So from there now, we get the profit. So the first one will be 1150 times 10 minus 800 times 10. And this one gives us 3,500. And they are the same, so it is 3,500 everywhere. That way. The next one will be 10 times 1150 minus 20 times 800. That gives us negative 4,500. Then 20 times 1150 minus 20 times 800. That gives me 7,000. Then the same case we apply here, 7,000. 10 times 1150 minus 30 times 800 is negative 12,500. 20 times 1150 minus 30 times 800 is negative 1,000. And then 30 times 1150 minus 30 times 800 is 10,500. It's 10,500. So with that, I can prepare my payoff table here. The summary. Summary, which we call the payoffs table. The payoffs table. And in this payoffs table, So here I have the option of 10, 20, 30, and this is probability. Here I have the outcome of 10, 20, 30, and then expected monetary value. Expected monetary value. If I work with my figures being thousands, with my figures being thousands, this is 3.5, 3.5, 3.5. This is minus 4.5. This is 7. This is 7. This is minus 12.5. This is minus 1 and 10.5. And the probabilities are 0.36, 0.42, and 0.22. Those are the probabilities. So I told you not every question that will require you to compute these payoffs. Most of the questions will be given like that. You will have the payoffs table already provided. So then from there, you tell us decision made using number one, I told you it's called max rule. Max rule. And in max rule, I told you what to do. You come here and tell us this is option. And then you extract the maximum payoff. Option, the maximum payoff. So the option of 10, 20, 30. In 10, the maximum payoff is 3.5. In 20, the maximum is 7. In 30, the maximum is 10.5. So we said this rule, you interpret it as select the maximum of the maximums. So the maximum of the maximums is this one. So the advice here is that they should produce 30 units. Is that they should produce 30 units. The next rule is max min. Max min rule. Now in the max min rule, again, you get the option here. And now you extract the minimum payoff. The minimum payoff. So the minimum payoff, or rather the option here are 10, 20, and 30. When you go to 10, the minimum is 3.5. When you go to 20, the minimum is minus 4.5. When you come to 30, the minimum is minus 12.5. So this rule, I told you, it means select the maximum of the minimums. Select the maximum of the minimums. That happens to be this one. So the advice that we are going to offer is that they should produce 10 units. They should produce 10 units. Rule number 3 that we know of. Rule number 3 that we know of is called Rapri's rule. Rapri's rule. And in the Rapri's rule, I told you, you get the option here, and you get what we call simple average. Simple average payoff. You get what we call simple average payoff. Now, the simple average payoff, in the option of 10, you take 3.5 plus 3.5 plus 3.5. Now you divide by 3 because there are 3. You come to the option of 20, you say minus 4.5 plus 7 plus 7. You divide by 3. Then the option of 30 is negative 12.5 plus minus 1 plus 10.5. You divide by 3. That is how you get the simple average payoff. So this obviously will be 3.5. So minus 4.5 plus 14 divided by 3 is 3.2. Then minus 12.5 minus 1 plus 10.5 divided by 3 is minus 1. Is minus 1. So according to this Rapri's rule, you are supposed to go for the highest. So the highest is this one. So the advice that we are going to offer is that we should produce 10 units. We should produce 10 units. The next rule is called Howitt's. Is called Howitt's rule. Is called Howitt's rule. And in this Howitt's rule, we have the option here, and then you get something we call weighted average payoff. Weighted average payoff. Weighted average payoff. And what happens here? You come to the option of 10. Then you take alpha. This question already has given us alpha 0.8. You multiply by the best payoff. The best payoff is 3.5. Plus 1 minus alpha multiplied by the worst payoff, which is 3.5. And the answer will still be 3.5. Then you come to the option of 20. You take 0.8 multiplied by the best. The best is 7 there. Plus 1 minus 0.8 multiplied by the worst. The worst there is minus 4.5. Then you come to 30. You take 0.8 times the best. The best there is 10.5 plus 1 minus alpha multiplied by the worst. The worst there is minus 12.5. So when you seek help from your calc, you should be able to get 0.8 times 7 minus 0.2 times 4.5 being equal to 4.7. and then 0.8 times 10.5 minus 0.2 times 12.5 as 5.9. It's 5.9. So once again, you go for the highest. So the highest here is 5.9. So the advice is that we should produce 30 units. We should produce 30 units. Just a minute. So that is how it. The next rule is called most likely event rule. Most likely event rule. Now, in the most likely event rule, you simply come and check which one has the highest probability in the original table, and it is this one. Then you check whether the name of that option is, or about that outcome, is existing in the names of the options. So you can see there is a 20 here. So the advice is they should produce 20. They should produce 20. That one is as simple as that. We take the option whose name is similar to the outcome with the highest probability. The next one that we use is called expected monetary value rule. Expected monetary value rule. And this one, we have the option. We have the option here, and then we compute EMV without information. EMV without information. EMV without information. Now, the EMV without information is simply when you count to 10, you say 3.5 times the probability of 0.36 plus 3.5 times the probability of 0.42 plus 3.5 times the probability of 0.42, and the answer will be 3.5. 20, it is minus 4.5 times 0.36 plus 7 times 0.42 plus 7 times 0.42. This becomes minus 4.5 times 0.36. Sorry, this is 2 here. Even here it was 2 that way. So plus 7 times 0.42 plus 7 times 0.22. I'm getting 2.86. 2.86. Then when you go to 30, is minus 12.5 times 0.36 plus minus 1 times 0.42 plus 10.5 times 0.22. So minus 12.5 times 0.36 minus 1 times 0.42 plus 10.5 times 0.22. And this is giving me negative 2.61. So those values we normally record here in the original table as 3.5, 2.86, and negative 2.61. Negative 2.61. Sasa, what you do, you select the highest. So the highest is this one. When you select that, then you give us the advice that we are supposed to produce 10 units. We are supposed to produce 10 units. Okay, the next rule is called service rule. Before we even do the service rule, we need to prepare what we call the opportunity losses table or the regrets table. The regrets table. So here we have the option 10, 20, 30. Then we have the probability. When you start with 10 here, I told you what you do. You pick the highest in that outcome. The highest is 3.5. Now this one, you subtract all the others from it. So you subtract 3.5, you subtract 4.5, you subtract 12.5. So this becomes 0, this becomes 8, this becomes 16, and the probability is 0.36. You go to the outcome of 20. When you are in 20, the highest is 7. You pick 7. Then you subtract the others from it. So you subtract 3.5, you subtract 7, you subtract minus 1. So this leaves us 3.5. Then this is 0 and this is 8, and the probability is 0.42. The probability is 0.42. Then you go to the one of 30. The highest there is 10.5. 10.5. Now this one, you subtract the others. You subtract 3.5. You subtract 7. You subtract 10.5. This is 0. This is 3.5. And this is 7. Then you compute the expected opportunity loss. The probability here is 0.22. The expected opportunity loss You just multiply these payoffs with the probabilities, just like what you have done here with the EMV. So I will not write, we just compute straight. So it will be 0 times 0.36 plus 3.5 times 0.42 plus 7 times 0.22. And that gives me 3.01. That gives me 3.01. Then the other one will be 8 times 0.36 plus 0 times 0.42 plus 3.5 times 0.22. I get 3.65. Then 16 times 0.36 plus 8 times 0.42 plus 0 times 0.22 is 9.12. That is how you get the expected opportunity losses. So when they tell you to make a decision using now what we call the savage rule, using the savage rule, savage, some people call it regrets rule, regrets rule. We have the option here, and then you get the expected opportunity loss. We have the option, and you get the expected opportunity loss. So in the option of 10, 20, and 30, this is 3.01, we already have computed, 3.65 and 9.12. 9.12. This one, you go for the lowest. The lowest is this one. So the advice that you offer is that they should produce 10 units. That is the advice that you offer when you're using that rule. And the last rule that you can come across, we want to call it minimax regrets. Minimax regrets rule. Minimax regret rule. So in this minimax regret, what you do, you have the option here, and you get the maximum regret. The maximum regret. Remember, regret is the opportunity loss. So now, here we have 10, we have 20, and 30. In the regret table here, in 10, the maximum is 7. In 20, the maximum is 8. And in 30, the maximum is 16. The maximum is 16. Those are the maximum regrets. So you are supposed to take the minimum of those maximums. So that is this one. And therefore, you advise them that they should produce 10 units. That they should produce 10 units. Okay. The next question that I want to handle, now that you kept quiet, is the question of still that September 2021, question 5B. Question 5B. Now the question says, a recent inspection of boards produced by a certain company revealed that 40 boards inspected I think were defective. 5 bolts are picked at random and inspected. Assuming that the distribution of defective bolts follows the Poisson distribution, calculate the probability that at least 3 bolts are defective. So the first one, we are told to use Poisson probability distribution. And in Poisson probability distribution, I told you the formula is the formula that we use is probability of X is E raised power minus lambda raised power X, you divide by X factorial then we are told the probability of at least 3. And before we get that, we need to know lambda. Lambda is the mean. And the mean I think my question is something that was missing, but it's supposed to read, revealed that 16 out of the 40 boards inspected were found defective. Should have read that way. 16 revealed that 16 out of 40 bolts inspected were found defective. So if that is true, then the mean is that 16 you divide by 40. That gives you 0.4. So when the question says that the probability of at least 3 when you are told at least three, it means that your x is greater than or equal to 3, which exactly means it is either 3 or 4 or 5, because we are told that the boards that were picked, there were 5. So substituting or computing the probability that x is greater than or equal to 3 will be equal to e raised to power minus lambda. Lambda is 0.4 times 0.4, you raise to power 3, then you divide by 3 factorial, you say plus e raised to power minus 0.4 times 0.4, you raise power 4, you divide by 4 factorial, plus e raised power minus 0.4 times 0.4 raised power 5, you divide by 5 factorial, you divide by 5 factorial. Now take your calculator so that we compute that. So if you remember what we said, you can say shift natural rule minus 0.4 times 0.4 raised to power 4 raised to power 3. You divide by 3 shift factorial plus shift natural rule minus 0.4 multiplied by 0.4 raised to power 4, divide by 4, divide by 4 shift factorial plus shift natural rule raised to power minus 0.4 times 0.4 raised to power 5, divide by 5 factorial equals I hope I've computed it well. Let me repeat again. Is 0.4 times 0.4 raised to power 3. You divide by 3 factorial, then plus e 0.4 times 0.4 raised to power 4. You divide by 4 plus 0.4 times 0.4 raised to power 5. You divide by 5 factorial. Yeah, I'm getting 0.00792. 0. Okay. Then the next one we are told to do binomial distribution. Binomial probability distribution. Binomial probability distribution. Now the formula for the binomial, the formula is probability of X is N combined X, P raised power X, Q raised power N minus X. So in this case, success, we say rate success to be equal to effective. Now, success is that which we are looking for. So the question is telling us to look for the defectives. So the defectives are our success. And therefore, P, the probability that a bulb is defective is this one, the mean, still 16 out of 40, which is 0.4. And therefore, it follows that Q should be 1 minus 0.4, which is 0.6. 0.6. Then N is the number of bulbs which are involved. There are 5 of them. N is 5. So according to the binomial, we are told, assuming that the distribution of defective bulbs follow the binomial distribution, calculate the probability that at most 3 are defective. So when you are told at most 3, what that exactly means is that X is less than or equal to 3. So that can either be 0, 1, 2, or 3. That is the meaning of that. So with that, then, we will argue like this. Probability that X is less than or equal to 3 will be 5 combined 0 multiplied by 0.4 raised power 0 multiplied by 0.6 raised power 5 according to our formula there, plus 5 combined 1 multiplied by 0.4 raised power 1 multiplied by 0.6 you raised to power 4 plus 5 combined 2 multiplied by 0.2 you raised power 2, 0.4 that is, then multiplied by 0.6 you raised power 3 plus 5 combined 3 multiplied by 0.4, which is raised to power 3, multiplied by 0.6, which is raised to power 2. Now we know how to do the combinations using the calc. So you just use your calc and say 5 combine 0 times 0.4 raised to power 0 times 0.6 raised to power 5 plus 5 combine 1 times 0.4 raised to power 1 times 0.6 raised to power 4 plus 5 combine 2 times 0.4 raised to power 2 times 0.6 raised to power 3 plus 5 combine 3 times 0.4 raised to power 3 times 0.6 raised to power 2 equals, the answer that I'm getting is 0.91296. So that is how you use binomial probability distribution. Binomial probability distribution. So the next question that I want to handle was tested in May 2021 as question 3C, no, question 1C, and the question is normal probability distribution. It's a normal probability distribution. So in that one, we are told the registrar of Ef3 University has observed that the grade point aggregate of the university students is normally distributed with a mean of 2.75 and a standard deviation of 0.4. So the probability that a randomly selected student from the university has a grade between 2 and 3. So if you are told to get the probability of between 2 and 3, you know very well what we said. So between 2 and 3, we draw. So here we have the mean X bar, which is 2.75. Standard deviation is 0.4. So 2 is somewhere here, which is X1, 2. Then X2 here is 3. That way. So we need to get Z1 as X1 minus X bar. We divide by standard deviation. So this is 2 minus 2.75. Divide by 0.4. Then Z2 will be X2 minus X bar. We divide by standard deviation. This will be 3 minus 2.75. Divide by 0.4. So 2 minus 2.75 divided by 0.4 is negative 1.88 because the values of Z are given to 2 decimals. 3 minus 2.75 divided by 0.4 is 0.63. 0.63. Now from the tables, probability that we are between 2 and 3. So you take your normal tables. When you go to the normal tables, these ones, you look for 1.88. huku mwisho it is 0.4699. 0.4699. Then you go looking for 0.63. 0.63 is 2357. 0.2357. So when you add those two, when you say 0.4699 plus 0.357, the answer is 0.7056. How you get it? The next requirement is the lowest grade point that should be obtained by a student for him or her to be among the top 10%. So the top 10 the lowest mark in top 10. The lowest mark in top 10. What that means is that once again, we have our X bar here of 2.75. Now this mark here, X1, is what we do not know, but we know the whole of this should be 0.1. Should be 0.1. And because we know from here all the way to the end is 0.5, it then means this gap here must be 0.40. Must be 0.40. The standard deviation here is still 0.4. The standard deviation is 0.4. We are going to use this formula here. We are going to use this formula that X1, we're looking for X1. If you make X1 the subject of this formula, then this one to join them there, it will be X bar plus Z standard deviation. Plus Z standard deviation. If you make X1 the subject of this formula, the subject there. Now from the tables, obviously this is Z1. Z1, you go inside the tables. And I've been telling you when we talk of inside, we are talking of these values. So huko ndani utafute 0.4. If you can't get it, you go for the value that is so close to it. Now, according to the table I have, the value that is so close is 1.28. 1.28. 1.28. The value in the row is 1.2 and in the column 8. It then means that X1 should be 2.75 plus 1.28 times 0.4. And that then will give us 2.75 plus 1.28 times 0.4. And I get a mark of 3.262. So if you want to be among the top 10, the lowest mark you should get is that 3.262. And assuming that the university has a total of 10,000 students, determine the number of students having a grade point aggregate of 3.7 or higher. So those who have 3.7. So at least 3.7. Now at least that means 3.7 or higher. So when we are told 3.7 or higher, it means here we have X bar here, which is 2.75. Then 3.7 here, X1. We are looking for these ones on the higher side. Standard deviation is 0.4. 0.4. So Z1 will be X1 minus Z bar divided by standard deviation. So this will be 3.7 minus 2.75. You divide by 0.4. So if you say 3.7 minus 2.75 equals divide by 0.4 is 2.375 or 38. Now from the tables, probability that X is greater than or equal to 3.7, it will be 0.5 minus. Remember we say minus because what you are going to get is from here to here when you read the tables. So you go to your tables after 3.8, rather 2.38, 2.38. I'm getting 0.4913. 0.4913. So if that is what you get, then you tell me 0.5 minus 0.4913 is 0.0087. So the number of students, will be the probability you multiply by 10,000 because we are told the school has 10,000. That tells you you have 87 students. That tells us that we have 87 students. Okay. The next question that I want to handle is a question of November 2020. November 2020, question 2A. And this question is on what we call multiple stages decision. Multiple stages decision. The question says that a baker must decide whether to bake brown bread or white bread for a new market. So we can start with a sketch. So this guy must decide whether he's going to go for brown or white. Demand at the market can either be small or large, with the probability of that. So demand can either be small or large. Demand is small or large. And you can see there are two probabilities. Now, if the brown bread is baked and demand proves to be high, the baker may choose not to expand. So if the brown bread is baked and demand is high, so it is large, then you will choose not to expand. So no expansion, you choose not to expand, or to expand. So you choose to expand or not to expand. You choose to expand or not to expand, and we are given the payoffs there. Now, if brown bread is baked and demand is low, if demand is small, there is no reason to expand. So here, you will not expand. You will not expand. Now, if white bread is baked and demand proves to be low, the choice is to do nothing. So if you bake the white and demand is low, you do nothing. You do nothing, and you get payoff 90. Or you advertise. Or you advertise. The response may be either modest or sizable. When you advertise, you can get modest or sizable response. With those probabilities, and if it is modest, the payoff is estimated to be 50,000, and the payoff grows to 340 if the response is sizable. Now, if the white bread is baked and demand turns out to be high, the payoff is 1.4. Yeah, so that means there is nothing there. So you are told to draw a decision tree. So as I told you, and as you have seen in the sketch, you count how many tails you are going to have. You are going to have 1, 2, 3, 4, 5, 6, 7. So we are going to do a decision tree that has 7 tails. A decision tree that has 7 tails. And in making our 7 tails, we're going to have 1, 2, 3, 4, 5, 6, 7. So here we shall have the payoff. So you're saying 1, 2, 3, 4, 5, 6, 7. And I told you when you're drawing a division tree with a sketch now in place, you start from the reverse. So this is the one that has many outcomes. So I'm going to start here. Going to start here. Going to start here. And this is where we are told the response will either be modest or sizable. The response will either be modest or sizable. And this is when you have chosen to advertise. It's when you have chosen to advertise. This is advertise. And here is when you have chosen to do nothing. Remember, I told you that the outcomes you use in complete rhymes. Sorry, the options you use in complete rhymes and the outcomes you use complete rhymes. So this is where we are told we will do nothing. We will do nothing. And this is when demand has turned out to be this is a small demand or low demand. This is when it is low, and this is when it is high. When it is high. And this is when I think your media son cannot have enough good space. So this is low. This is high. And this is when you have baked white. Let us now go to these ones. Now, this is where you do no expansion, no expansion. And here there is expansion. And here we have been told no expansion. No expansion. And one I can still combine it. This one I can adjust it. Instead of creating a connection point, I can make it full so that I say this is a row. Was it true? If it's baked and proves to be high, you may choose to expand or not expand. Yes. So this is high. Remember, this is now our decision tree. So when you have drawn the sketch, it becomes very easy. Copy from the sketch. You have seen me do. So this is brown. So if I may fill the figures, we are told you can decide to do white or red. Demand at the market can either be small or large, with the probabilities estimated to be 0.3 and 0.7. So small is 0.3 and high is 0.7. The same case here, 0.3 and 0.7. Those are the probabilities. Then, if the brown bread is baked and demand is proves to be high, then you may choose not to expand. So when there is no expansion, the payoff is 350,000. Or you choose to expand and you get 420,000. 420,000. If the brown bread is baked and demand is low, there is no reason to expand and the payoff is 310. 310,000. If the white bread is baked and demand proves to be low, the choice is to do nothing. Now, when you do nothing, you get minus 90,000. Or to stimulate demand through local advertising, the response may be either modest or sizable, with the probabilities of modest being 0.4, sizable is 0.6, and the payoffs are either 50,000 here, and this other one is 340,000. 340,000. If the white bread is baked and demand stands out to be high, so high, we have a payoff of 1,400,000. So those are the payoffs. So I can number these ones this way. This one I can call it number 1. This one I call it number 2. This one I call it 3. This one I call it 4. This one I call it 5. And this one I call it 6 for my computation purposes. Then below that, I have computation of EMV at node. Let me start with the node 1. Computation of EMV at node 1. So node 1, and I'm going to use the figures in thousands because of my space. So it is 0.4 times 50 plus 0.6 times 340. So 0.4 times 50 plus 0.6 times 340 is 224. Is 224. And then when I get to number 2, when I come to number 2, you can see the lines going out are incomplete. So here you don't multiply, you select. So it is the higher. It is the higher. And the higher of these two is 420. The higher of those two is what you pick, 420. When we come to number 3, you can also see these are our options. They are incomplete, so it's a case of selecting. So we take the higher between this minus 90 and what we have here in number 1. So it's also a case of the higher. And the higher is 224. And it's good to show where you are saying higher. Like now here, 420 is good. You mark that way that you have chosen to expand. Then here we have chosen to advertise. That's where we have the higher. The 420 and the 224. Then when I go to number 4, you can see the lines are complete. So it's a case of multiplication. So I'll say 0.3 times 310 here plus 0.7 times what I got in number 2. Number 2, I have 420. 420. So if I say 0.3 times 310 plus 0.7 times 420 is 387. 387. Then we have number 5. We have number 5. Number 5 is also a case of complete lines, so we'll have to multiply 0.3 times what we have in number 3. Number 3 is 224 plus 0.7 times what we have in numbers in this one, which is 1.4, 1400. So 0.3 times 224 plus 0.7 times 1400, I'm getting 1047, 1047.2. And finally, when I come to number 6, is a case of selection. So we go with the higher here between 4 and 5. The higher is 1047. The higher there is 1047.2. 1047.2, which has been gotten from number 1 here. Sorry, number 5. And therefore, the advice that we are going to give these friends of ours is that they should bake white bread. Bake white bread. They should bake white bread. And that is what will happen if someone was to ask you to compute value of information. value of information. The other question that we began with, I forgot to compute, but you should know that the value of information is the lowest EOL. I think we had gotten that. And you can also check in your books how we compute that. But for this one, I told you the value of information is simply the difference between these two, what you have in number 4 and what you have in number 5. So that is 10.47, another 1047.2 minus what we had in number 4. Number 4 was 387. 387. So if you say minus 387, you get 660.2. 660.2. So my time is over, but I still wanted to do the same paper, question 2B and question 3A. So I suggest that in your own time, you look at those questions. The same paper of May or rather of November 2020. Hizi tu zinafuata hapa. You remind yourself how to run and how to compute the regression. And you also remind yourself question 1B. Question 1B, how to do the hypothesis. How to do the hypothesis. So that is all from my end for today. And I want to take this opportunity to wish you all the very best in the forthcoming exams. I believe that I have done a good job that is not only enough to make you pass, but also to get an award in the paper. So go to the exam room knowing that you are well prepared, knowing that you have already passed, and that would be good. We also want to sincerely thank you for choosing Destiny to be your trainer. We know that there are many other places you could have chosen to go to, but out of your own free will, you chose us. We want to say thank you, and we welcome you to join us in the next semester, which is beginning on 11th of this month. Now we are in April, so that we can go together to the next level. Also, continue marketing us, continue encouraging your friends to come and join us. Let them know that they are missing a lot for not being with us. Thank you so much. God bless you. See you over lunch hour as we do prayers for the exams, and that would be great. Thank you so much. God bless.